Good morning, everyone. I hope all of you are doing fine. And today we are going to talk about what we saw a snippet of it is junctions in semiconductors, right? What is this junction, what you are talking about? Because you have been talking about the application of it, and one of the application we talked last time was what is inside a FASTag, and we said that a junction, right? It's very much there, and there are different kind of junctions. So let's talk about what kind of junctions are there inside these devices, which makes a particular functionality, right? A very simple junction which we talked about. So unless you have, so let's talk from physical perspective first, so that we can understand where they are originating from. So if there is an N silicon, and inside this N silicon, let's say if I were putting another N silicon, right, and which has the similar doping to this, would you think that there is any junction would be there? No, the reason is why it would not be, because basically it is like that it's the same environment electron, whatever electron is there, is experiencing, right? So if the same environment it is experiencing, then there is no problem. It's like a basically the same water. If in a bucket you are putting one more mug of water and somebody is really let's say swimming in that water, he would not experience any problem, right? Because the same water. But if you put a oil, let's say a mug of oil or some other fluid, then that person would feel, oh no, it's not the same environment, right? So that is the case, which is what happens very simply in junctions, is that you are changing the environment of your semiconductor. So this is N silicon which you started with, but on top of that, if you put a doping which is like a P silicon, that means you are basically bombarding some boron atoms here, which are changing the or diffusing the boron atoms, which are changing this part of the. So then when the electron is in this part, it is okay because it's the same environment. But as soon as it tries to go to this part, now it is saying, oh, there is a different environment which is there, right? And this environment is originating because, or how do we characterize this, is with a junction, right? So now, is this the only way to make junction, or there are other ways? Because here it is, you are still saying these are two silicon which are there. Then we talked about another. So in the fast tech example itself, we talked about another kind of junction where rather than putting a so I have the semiconductor, rather than putting a p semiconductor or different kind of doping, I could put a metal here, right? So this is, then we will call it metal semiconductor junction, because now again electron is going to go feel the different environment, right? Because there is a metal, this is your semiconductor, or which is we call ms junction. Anything else what we can do? Obviously you can see that if this thing is limited, you could put different dopings at different places. Metal is there. What other materials we have talked about? We could put a different material itself, right? So this is silicon. Let's say if I put another material on top of this, for example, let's say I put germanium, right? Different material. Obviously there is going to be a junction. This is again a junction, because electron is again going to feel the same different environment as soon as it approaches there. Then what else? Is this the only way? Other ways, other materials which we can, other than semiconductor, what other materials do we have? We can have a dielectric put in there, right? So this is the oxide which you put in, right? So this is again a junction which you have formed here, right? And on top of that, if we were putting a metal, then you remember this device which we have talked also in a video, what is inside a CCD or image sensor. This is the device which is there, right? A metal oxide semiconductor, which is what we know as the MOS, which is the heart of a MOSFET. So that is coming, there is a junction there also, right? Which is the oxide semiconductor junction, which you see, so there are, this junction is coming wherever you see a different environment, or this electron is going to see a different environment, you will see that there is a junction there. Now, how strong is that environment? Would it let it feel it too much, or can you modulate that environment? All of these are the different questions, and one of this we are going to explore today, right? So let's start with a very simple or the heart of it, all of this, which is we understand, because it's more holistic understanding we can get if we just. So what we do is we are taking cut line in this structure. This is, let's say, the first structure. In the cut line into this structure, the second structure, sorry, right? So in this cut line, when we draw, you will see that the P is from the top. If this is direction we are drawing, right? This is, let's say, my X direction. This is the direction I'm drawing. So there is a P, then suddenly you will see there is an N, right? This is how you're going to see this device along a cut line. So that means in this figure, you are only going to see in one particular direction how this looked like, right? So this is your diode. Now let's talk about what is this junction? How do you, when you tell me that I am going to see a different environment, or the electron here is going to see a different environment, I understand that because there is a somehow the environment has changed because I have doped it. But because of that, what is happening to when you say it's a junction, right? What is happening near this boundary? That is what I want to understand. For that, you have to understand what is there in the boundary, right? So what is there here? Okay, so what I mean by what is there, we know when there is an n-type doping, there are a lot of electrons which are there, right? This is the meaning of n-type. The p-type doping, I know that there are a lot of holes here, right? Which are feeling these are the home for me. For electrons, they are saying this is the home for me. Okay, good. What is happening here? Which is at the junction, are there electrons? Are there holes? What are there? What is there? That is the question. So let's look at it. What is going to happen when you combine? So let's say these were two different pieces initially, right? So that is the thought experiment you can think of. This is one piece P. This is another piece which is N, right? There are a lot of electrons here. These were there. There are a lot of holes here. This is the case which was there initially. And then what you did is you brought them together. You said, okay, I am going to put a different environment for all of you. So for holes, be ready, different environment coming. For electrons, be ready, different environment coming. So when I put this guy like this, right, where this is the P, this is the N, what is going to happen to these holes and electrons? Let's see. So what is going to happen to these holes and electrons? We can see what is going to happen. So the holes are going to feel, oh, there is a lot of me here, but there are very few here. What do I do? Should we go towards them? Our brothers, our long lost brothers. So that is a kind of flux which you will see, or due to holes. Why is this? Because of the phenomena which we have talked about in one of the video. Yes, you are right. When a higher concentration to lower concentration something is going, which is our diffusion. Another one where you see electrons, lot of electrons here, very few here. Again, electrons are, oh, there is very few, let's go there. They are feeling alone. That is your electron flux, right? Which is also happening due to diffusion. So then what is going to happen when this diffusion start to happen? This is happening, and this happens obviously for the electrons or holes which are very close to the interface, right? Because they will be the first one to enter from that side. So it's like whenever there is a diffusion happening, it's always wherever the membrane or the physical connection is, from there it would start to move, right? So now from there, if this is moving towards this side and electron is moving from this side, right, what is going to happen is these electrons, they are going away from that region and they are going towards the other side. So that means what are they leaving behind? Because so that is the region I can say there is no electron, right? So let's create those regions where there is no electron or no hole, right? So here we say there is no electron. Why no electron? Because they have moved. Similar to this, no hole. But what is left then if there are no electron holes? And that is where you will see that if you remember that picture, how we were doping, right? If you remember that picture of the bond model where there was silicon and when, let's say, we were putting a phosphorus, right? And we know that phosphorus atom has an electron attached to it, right? Suppose if this was a boron atom, then the boron atom is like a having a hole attached to it, right? So what is going to happen from this portion? You're going to see that this electron, if this goes away, right, this goes, sorry, this goes to this side. So I wanted red. Yeah, this side. Similar to this, the hole goes to this side. What is left? And you guessed it right. You have made your p type, or the p, this will become p plus, because, which is what we can know as a also Nd plus. Nd means the density of phosphorus. Similar to this, your B will become minus, which is similar to Na minus, right? So what is left then in this region are your negative charge or positive charge in the whole, in the electron side? You guessed it right, it's the positive. And is this the whole positive? No, it is not. It's the phosphorus atom which has got positive charge. So that is why these are donor atoms. Atoms, not electrons. I hope that is clear to you. What is an electron? What is an atom? If it is not, please post in the comments. We will talk about what is an electron, what is a hole. Similar to that, there is a acceptor atom here, right? And that is what is there in the, and what does this do? This makes a junction. What is a junction now? Because hole is saying, let me go to the other side, please, because there are very few that side. Electron is saying, let me go to the this side. Hole is saying, let me go to this side. But what is this region doing? If you see closely, this region's electric field, what direction it is pointing in this region? What is the direction they are pointing? Positive to negative. You guessed it right. So if this is the electric field, because of diffusion, you are seeing that the hole want to go there because of diffusion, but because of a opposite electric field, the whole field, and this is the junction, because due to junction electric field, right? Yeah. So this is the due to junction electric field that you see. This is going back. Similar to this, here also you will see due to junction electric field, this E or FEE, right? It would go back. Now you see that there's an opposing force which has come from somewhere, and that is resulting from these donor atom and acceptor atoms, right? And that is the reason why you see when you put them together and you wait for some time, the whole process will neutralize, because there is a to diffusion which was happening in this direction. Let me use the same color. So diffusion, which was, this is the whole diffusion, this was the electron diffusion, but now there is an opposing force. Opposing force is junction electric field, right, which is applying drift to these, which are giving you hole is going into this direction or electron is going into this direction, right? So this is due to junction electric field. So then there is an opposing force, and this phenomena stops at some point, right, which is what, when it becomes that there is no net change, is what we say as the equilibrium, that this is our state where nothing interesting is happening. It's the same way that everything has achieved a state where this is okay, this has stopped, right? So then, because statistically we know that it would never stop. If you have seen the video of generation recombination, you know that there is a mechanism. Even if your diffusion drift is not there, you do have carriers which are generated due to thermal generation, right? So that is why equilibrium is that state where this has found its balance, right? The balance is found. It does not mean the things have stopped. That is why it is very important to understand. We say that this is stopped, which I also use in the video, but it's not technically correct. Technically, there is a balance which is found, right? So balance is found here, and that is where this junction and whatever we call this part, where there is another field coming, is a, we call it PN junction, right? Or a depletion region. Depletion. So PN junction can be said the whole device, but junction meaning this is the physical junction. Because in the other device, hole is like a बहुत सारे holes हैं यहाँ पे. Electron is like बहुत सारे electrons हैं. But this is where they feel the interesting phenomena, what is happening. And this is what is the basis for why diode behaves the way it behaves, right? Or why does the rectification. Because this is the very basis of that device, which we will talk in another video. For now, today we will end here. That I hope that this what we talked about, probably you got some idea what are the different junctions in semiconductor we talk about, and this is just scratching the small with small some cases I have just talked about very briefly about junction, but there are many junctions which can come due to, but idea is same, either different material, right? Here the same material is there, but different properties of the material is there, right? Different properties means n type, p type. Here, yeah, sorry, this is same property. No, it's not different. um, so there is no junction, so that was no junction here, right? That was the idea. Here there's junction because different, so this is different property here. And then you go about here, you see different materials. Ooh, right? Here you see again different materials, but these are metal. Here semiconductor. There you see now again different materials. So these are the few cases, and if I'm missing something, please do tell me what are different kind of junctions you have seen. Okay, with that, that's where we end, and happy learning, happy growing to all of you. Keep doing that.